Did you know that every major space agency in the world, from NASA to the European Space Agency, all agree on one thing: the Earth is round? It's a fascinating and, to some, even surprising fact, especially when you consider just how vast and mysterious our planet is. There are still many things we don't fully understand about Earth, from the depths of the ocean to the most remote areas of the poles. But the shape of the Earth? That's one mystery we've actually solved a long time ago. Yet despite all the scientific advancements and the overwhelming evidence, the flat Earth theory has been experiencing a surprising resurgence in recent years. You've probably heard someone mention it online or maybe even in person, claiming that our planet is in fact flat. But have you ever stopped to ask yourself, where does this theory come from? And more importantly, what are its main arguments? Today, we're going to take a deep dive into this debate and analyze these claims using solid scientific evidence. One of the key arguments made by flat earthers is based on what we can see with our own eyes. They say the Earth looks flat when viewed from a distance, especially when you're standing on a large open plain or flying in an airplane. They argue that photos and videos showing the curvature of the Earth, often taken from space, are manipulated, part of a large-scale conspiracy designed to trick the public. Sounds wild, right? But if you think about it, why would space agencies and scientists go through the trouble of creating such an elaborate hoax? This is one of the many points we'll be exploring further. Another major claim flat earthers make is that the concept of gravity, as we understand it, is incorrect. They argue that objects don't attract each other due to gravitational pull, as we've been taught. Instead, they propose alternative ideas to explain why things fall or why planets orbit. But before we get into that, it's important to note how well tested the concept of gravity is. It's not just a theory that exists on paper. It's been proven through countless experiments and is the basis for technologies we use every day, from smartphones to GPS systems. Lastly, there's a common misconception among flat earthers that the idea of a spherical Earth is a relatively new concept, that ancient cultures all believed in a flat Earth until modern science came along and changed the narrative. But that's not entirely true. In fact, as early as the 6th century BC, Greek philosophers like Pythagoras already speculated that the Earth was round. By the time of Aristotle, around the 4th century BC, the idea was largely accepted in educated circles, based on observations like the way ships disappear hull first over the horizon, or the round shadow Earth casts on the moon during an eclipse. So, how did the flat Earth theory resurface in modern times, despite all this historical and scientific knowledge? Let's unpack that next. Flat earthers also often claim that the horizon always seems to appear at eye level, no matter how high you go. To them, this is undeniable proof that the Earth is flat. Their argument is simple. If the Earth were truly a sphere, the curvature should be visible from higher altitudes, and the horizon should dip as you ascend. But the fact that we don't seem to notice this dip leads them to the conclusion that the Earth must be flat. They even reference photographs taken from high altitudes, which to the untrained eye can appear to show a flat horizon. Sounds convincing, right? But as we'll soon discover, these claims are not just misguided, but they can be easily explained through well-understood scientific principles. So let's break this down. First of all, the reason the horizon appears to be at eye level, even from high altitudes, is due to the immense size of the Earth. The Earth's curvature is so gradual that it's not easily visible without specific conditions, and certainly not to the naked eye or in casual photos. In fact, pilots flying at high altitudes or astronauts on space missions describe seeing a distinct curvature when they're at the right height, usually around 35,000 feet or higher. Special camera lenses, particularly wide-angle ones, can also distort images to appear flatter than they are. So, when flat earthers use these photos as proof, they're often misunderstanding how optics work. One of the most mind-boggling claims from flat earthers is their rejection of gravity itself. According to them, gravity doesn't exist. It's merely an illusion. They argue that objects do not attract each other as we've been taught in school. Instead, they propose other explanations, like a flat plane that accelerates upward, creating the illusion of gravity. This claim, however, goes against centuries of scientific research. Gravity isn't just some abstract idea. It's something we can observe and measure every day. From the orbits of planets to the way the moon influences ocean tides on Earth, the effects of gravity are undeniable and everywhere. To give you a better picture, let's look at how gravity was first demonstrated on a large scale. Sir Isaac Newton's famous law of universal gravitation in the 17th century was based on observing how objects naturally fall to the ground, how the moon stays in orbit around Earth, and how the planets revolve around the sun. These laws were later refined by Einstein's theory of general relativity, which showed that massive objects like Earth warp the space around them, creating the force we experience as gravity. Without gravity, the entire universe as we know it would fall apart, quite literally. Now, what does the scientific evidence say about the actual shape of the Earth? We've already mentioned satellite imagery, but it's worth diving a bit deeper into this topic because satellite technology is one of the most concrete ways we can directly observe the Earth's curvature. Satellites, orbiting thousands of miles above the surface, provide a bird's-eye view of our planet. And every single image, from government agencies to private companies like SpaceX, consistently shows a round Earth. These images aren't just pretty pictures. They're the result of decades of space exploration and technological advancement, offering us clear visual proof of the Earth's spherical shape. But even before the age of satellites, humans had long been aware of the Earth's curvature. Take lunar eclipses, for example. During these celestial events, the Earth casts a shadow on the moon, and that shadow is always round, no matter where the eclipse is observed from. This wouldn't be possible if the Earth were flat. The phenomenon of ships disappearing hull first over the horizon is another example of the Earth's curvature in action. If you've ever watched a ship sail off into the distance, you'll notice it gradually vanishes from the bottom up, something that can only happen on a curved surface. The evidence, when you put it all together, is staggering in its clarity. From satellite images and lunar eclipses to the effects of gravity on our daily lives, science consistently and overwhelmingly supports the reality that the Earth is round. The laws of physics give us some of the strongest evidence supporting the fact that the Earth is spherical. Let's start with gravity, the force we talked about earlier. Gravity isn't just some abstract idea. It's a fundamental force that governs how objects behave on Earth and throughout the universe. When you drop something, it falls toward the ground, right? That's gravity at work, pulling the object towards the center of the Earth. But this force wouldn't work the same way if the Earth were flat. On a spherical planet, gravity pulls everything toward the center, which explains why we don't feel like we're walking on a slope, even at the edges of the world. If the Earth were flat, gravity would act differently, and it would create all kinds of strange phenomena, like objects behaving unpredictably or water not staying level. But it doesn't stop there. Gravity also affects how oceans behave. The rise and fall of tides are a direct result of the moon's gravitational pull on the Earth. Because the Earth is round, these tides occur in a predictable, consistent pattern all over the globe. On a flat Earth, tides would behave in strange and uneven ways, with no consistent patterns across different regions. But we don't see that, do we? Instead, we see smooth, regular tidal movements, a clear indication of a spherical Earth. Einstein's theory of general relativity also gives us an incredible insight into how gravity affects not just space, but also time itself. According to this theory, time moves slower near massive objects because of their gravitational pull. This phenomenon has been observed and measured in numerous scientific experiments, such as those involving atomic clocks placed at different altitudes. Clocks closer to sea level, where the pull of gravity is stronger, tick slightly slower than clocks at higher altitudes. This difference, although tiny, can be measured with modern technology. The fact that gravity behaves this way offers more evidence that Earth must be round. After all, this warping of space and time wouldn't occur the same way on a flat surface. Now let's consider one of the most compelling pieces of evidence that debunks the flat Earth theory: the way ships disappear over the horizon. You've probably seen it yourself. When a ship sails away from you, standing on the shore, it seems to sink below the horizon until it's no longer visible. Why is that? If the Earth were flat, you would be able to see the ship getting smaller and smaller, but it would never vanish in that specific way. The reason it disappears is because the Earth is curved. As the ship moves further away, the curvature of the Earth causes the lower part of the ship to drop out of your line of sight first, followed by the rest of it. This phenomenon has been observed for centuries. In fact, this was one of the first clues to ancient sailors that the Earth wasn't flat. They noticed that ships coming into view from the horizon would first appear with just the mast visible, and only later the entire vessel. It's a simple, everyday observation, but it's also a powerful proof of the Earth's curvature. There's another interesting experiment that's been done to demonstrate the curvature of the Earth, which you can even try yourself. If you stand on a beach with a pair of binoculars or a telescope and watch a ship as it sails over the horizon, the ship will disappear from view just as expected. However, if you climb up to a higher vantage point, like a nearby hill, you'll be able to see the ship again. That's because from a higher position, your line of sight extends further around the curve of the Earth, allowing you to see more of the ship that had previously vanished. It's a simple experiment, but it's incredibly effective at showing that we live on a round planet. The overwhelming evidence, from gravity to time dilation to everyday observations like the horizon, makes it clear that the Earth is not flat, it's round. The more we understand the laws of physics, the clearer this becomes. And while flat earthers may raise interesting questions, the answers, based on solid scientific research and centuries of observation, lead us to one inescapable conclusion. The Earth is indeed a sphere. This phenomenon of ships disappearing over the horizon is something anyone can observe and even measure. It's one of the clearest indications that the Earth isn't flat. A flat Earth model cannot explain why a ship gradually vanishes from sight as it sails farther from shore. If the Earth were truly a flat disk, we'd be able to see the ship's mast or sail for much longer, essentially until it reached the so-called edge of the flat Earth. But that's not what happens. Instead, the ship dips below the horizon, piece by piece, proving that the Earth curves. And it's not just ships on the ocean that reveal this truth. Another powerful piece of evidence comes from high-altitude flights. Many people who've flown in planes have had the chance to witness the curvature of the Earth with their own eyes. When you're at cruising altitude, typically around 35,000 feet, you're high enough to see the horizon stretching far into the distance, and with the right conditions, the subtle curvature of the Earth becomes visible. This is particularly noticeable during long flights, especially when looking out across vast, uninterrupted areas like the ocean. The view from up there doesn't show a flat plane. It shows a curved horizon, something flat earthers often dismiss but cannot adequately explain. Even more compelling is the fact that pilots, astronauts, and other professionals who spend extended time at high altitudes consistently report seeing the curvature. It's not a phenomenon exclusive to astronauts in space, although their images and testimonies provide even more definitive proof. In fact, the International Space Station, ISS, which orbits the Earth about 250 miles above, offers constant views of a round, blue planet. The footage from live streams aboard the ISS, coupled with satellite imagery, is as real as it gets. In conclusion, the scientific evidence is overwhelmingly in favor of the Earth being a sphere. Whether we're looking at satellite images, the physics of gravity, or simple observations like ships disappearing over the horizon, the evidence is undeniable and compelling. So why then do some people still cling to the flat Earth theory? In many ways, it boils down to how fascinating and unconventional the idea is. Flat Earth theory challenges our most basic understanding of the world around us, making it an intriguing concept to explore. But just because something challenges the norm doesn't make it true. For many flat earthers, the theory might appeal to a sense of skepticism or desire to question authority. After all, questioning established beliefs is an important part of human progress. But when it comes to the shape of the Earth, the scientific community has gathered more than enough evidence over centuries of research. The Earth is not flat, and the more we observe, study, and explore, the clearer that reality becomes.